Good evening. Good evening, students. This is Amit Dahiya. I welcome you all in Master Amit Dahiya classes. Today we are going to learn about the converse of basic proportionality theorem and Thales theorem. So I hope you all understood the B.P.T theorem or Thales theorem. Now in this video we will go for the converse of basic proportionality theorem. Knows about the if you know about the basic proportionality theorem or Thales theorem, then you can understand the converse of basic proportionality theorem. Let's move ahead. First of all, you have to remember the statement of the basic converse of basic proportionality theorem. The converse of basic proportionality theorem, it is said that if a line divides any two sides of the triangle in the same ratio, if a line divides any two sides of the triangle in the same ratio, then the line is parallel to the third side. What does that mean? If a line divides any two sides, it might be AB and BC also. Now I have taken AB and AC. So now what is given? A line D is divide the two lines AB and AC in the same ratio means AD equal upon DB equal to AE upon EC. If this ratio is equal, then prove that DE parallel to BC. Then prove that DE parallel to BC. To prove this, let us go ahead saying that DE is not parallel to the BC. If a DE is not parallel to the BC, then another line is there, a DE dash. If D is not parallel, then we assume that DE dash is another line which is parallel to the BC. You have to remember this point. We are proving that converse of B.P.T theorem by using the contradiction. D is parallel, we have to prove, and we are saying that if D is not parallel, then DE dash is the parallel. If DE dash is the parallel, then by the basic proportionality theorem, if a line is parallel to the third side, it will divide in the same ratio of other two sides. Now move ahead. If D is parallel to the BC, then according to the B.P.T theorem, what it said that AD upon DB equal to AE dash upon E dash C. Other two sides in the same ratio. It means ratio of AD upon DB equal to AE dash upon E dash C. This equation number 2. Now, but given is that AD upon DB equal to AE upon EC. That is given from equation number 1 and 2. Left hand side is equal. If this AD upon DB is equal to each other, then right hand side must be equal. So if right hand side equal, then AE dash upon E dash C equal to AE upon EC. Now the point you have to remember, now add 1 both the side of the equation number 3. In this equation add 1. If you are adding 1 in this equation, then what will got? Then AE dash upon E dash C plus 1 is equal to AE upon EC plus 1. Then if you are taking the LCM is E dash C, then AE dash plus E dash C upon EC. Similarly here AE plus EC upon EC. Then AE dash plus E dash C will give us the AC. AC upon E dash C equals to here AE and EC also give us the AC, then upon EC. Now both numerator are the same. it means denominator must be equal. Denominator must be equal. If numerator is equal, then denominator must be equal. If equal sign is there, this is the equality rule. Then E dash C and E dash EC must be equal. E dash C is equal to EC. Is it possible? If you are looking forward the figure, you are going for the figure, then a figure is there, this. If E dash C, this point E dash C, from this point to this point E dash C equals to E dash C, is it possible? Yes, it is possible only when E dash and E coincide to each other. When it is possible only when E dash and E coincide to each other. So what is said that? So what we assume, that is the wrong, and we assume that we can say that D is parallel to the BC. Our assumption is wrong, so that's why our assumption is E dash is parallel to the BC. But we have to prove wrong. It is possible. It is not possible. Because of that, E dash C is equal to EC. It means E dash and E point coincide to each other. Then it is possible. So our assumption is wrong. So that's why DE parallel to the BC. Thank you. Thank you for watching. And please like, share and subscribe my channel, Master Amit Dahiya Classes. And please comment if you are having any doubt related to this converse of B.P.T. theorem and about the B.P.T. theorem. Have a good day.